Okay, this is Mrs. Lewis. Welcome to section 3.3. We're going to be discussing proportions. You'll have to excuse some of the background noise tonight or today. My children are in the other room playing, so you'll probably hear them a little bit. So before you start, make sure that you've got this page. These two, yours is probably going to be front and back, but you should have this section 3.3 lesson. This is your guided notes. As I write on the board, make sure that you're writing the same thing on your paper, and when you're done, you're going to file it in your SOAR binder, just like you have the other notes. So we're going to start with the definition of a proportion. A proportion is an equation stating that two ratios are equivalent. Two quantities that form a proportion are called proportional. So two ratios are equivalent. You can think of that as two fractions that are equivalent. So you're going to be you can think of these problems as determining whether or not they create equivalent fractions. So you can just kind of keep that in the back of your mind as we go through these. So our first one, I'll tell whether the ratios form a proportion. We've got 4/10 and 10/25. Okay. Well, one way to do this is to put it in its simplest form. 4/10 you can divide by 2. Divide by 2. That's going to give you 2/5. And then 10 to 25, you could maybe divide that by 5 and 5. All right, 10 divided by 5 is 2. 25 divided by 5 is 5. So both of these ratios are equivalent to the ratio 2 to 5. So these are equivalent, so yes. Part B, are the ratios 6 to 4 and 8 to 12 equivalent? So let's try the same approach here. If I put 6 to 4 in simplest form, I can divide by 2 on the top and the bottom. That's going to give me 3 to 2. 8 to 12, if I put that one in simplest form, I can divide that one by 4 on the top and bottom. Now you might have said to divide it by 2, and that's right, you could, but you could still keep going after you did that step. So I noticed that they're both divisible by 4. So that's going to get 8 divided by 4 is 2, 12 divided by 4 is 3. Is that the same? 3 to 2, 2 to 3? No, these are not equivalent. This is not equal, so we're going to say no. So now you can try on your own numbers 1, 2, 3, and 4 right here on the bottom of your page. Work these out on your paper, and then pause the video while you do this, and then you can come back and check your answer. Okay, these are the answers that you should have gotten for on your own 1 through 4. So in the first one, they're equivalent because the ratio 5 to 10 in simplest form is also 1 to 2. So these are going to be the same thing. Number 2, 4 to 6, you can put that in simplest form as 2 to 3. And 18 to 24, you can divide this by 6 and 6. That's going to be 3 to 4. So these are not equal. In number 3, 10 to 3 is already in simplest form. 5 to 6 is already in simplest form. So there's nothing that you can do there. These are not equivalent. In number 4, 25 to 20, you could divide that by 5 over 5. That will give you 5 to 4. And then 15 to 12, you could divide by 3 and 3. That will give you 5 to 4. Wait a minute. Maybe I messed up on that one. Did I mess up on that one? Did y'all get yes for number 4? So 5 to 4 divided by 3, that's 5. And that was yes. So, number 4 was yes. When we work with proportions, we like to talk about cross products. In the proportion A to B equals C to D, the products A times D and B times C are called cross products. So this numerator and this denominator multiplied together is the A times D. B times C would be if you multiply this denominator and this numerator. The cross products of a proportion are always equal. So in other words, if you've got this proportion where 2 to 3 equals 8 to 12, That is correct, because if you put this in simplest form, you can divide by 4, divide by 4, it would give you 2 to 3. So these are equivalent. We've been busted. What this is saying is if you do the cross products of this, you're still going to get the same. They're going to come out to be the same. In other words, if you do 2 times 12, 2 times 12 is 24. And then 3 times 8 is also 24. So that's what it's saying. That's what they mean by the cross products are equal. Now that's only true if you're working with proportions. And when you're working with a proportion, that means that you've got an equation. First of all, there's got to be an equal sign in the middle of these. And you're going to have one fraction on this side and one fraction on this side, and you can't have anything else at all in the problem in order for this to work. So you've got to have a one fraction or one ratio equal to one ratio. And if that's a proportion, then the cross products are going to be the same. Okay? All right, and then we're ready to look at example 2. In example 2, we're doing a problem that involves swimming laps. You swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So there are 2 ways that we can go about this. In the first method, we want to compare our unit rates. Okay, so we want to know, is the number of laps proportional to the time? So we need 2 ratios. The first ratio would be just for laps. The second ratio will be just for the time that it took. So for the laps, we did 4 laps, and we also did 16 laps. Okay, because it says unit rate, I'm going to put the smaller number on the bottom. So when I set up my ratio, because remember a unit rate is when you want your denominator to become 1, so I'm going to put my smaller number of laps in my denominator. So I'm going to have 16 laps to 4 laps. So those are the 2 things that I did, and I just need to see the ratio for laps. I want to set this equal, but I'm going to put a question mark because I don't know if it's equal. That's what I've got to figure out. Is this equivalent to my ratio for my time? So when I swam my 16 laps, how much time did it take me to do that? 16 laps was done in 12 minutes. So 12 minutes for the 16 laps. And then the 4 laps I swam in 2.4 minutes. Okay, so we've got a ratio for laps, a ratio for the time it took us to do it. We set it up so that we can find the unit rate by putting the smaller number in the denominators. And now we just need to see if this is a true proportion. Are these equivalent? So when I go to simplify this, I can divide both 16 and 4 by 4 to get that in my simplest form, or to get it down to a unit rate. So that will be 4 goes into 16 4 times, goes into itself once. So and the laps cancel. So you've got 4 equals with a question mark. And I need 12 divided by 2.4. Okay, feel free to grab your calculator if you want to. 12 divided by 2.4 gives me 5. And my minutes cancel again. So I'm getting 4 equal to 5. So that tells me that no, the number of laps was not proportional to the time. Okay, so no, my laps are not proportional to my time. What does that really mean? Okay, what is you can think of this as meaning that you were not able to do the same distance in the same amount of time the 2 times that you did it. So one time you just weren't swimming as hard. Maybe you had a current. I think it was in a pool though. So maybe for whatever reason, maybe you were just tireder the second time, so you weren't moving at the same rate. So they're not proportional. Now method 2, it's just another way that we can answer the same question. So to use a cross products property, we're going to go back to the way we had it set up before. We had 16 to 4 equals, with a question mark, 12 to 24. Okay, this time we're going to do cross products. So we're going to multiply 16 times 2.4. You do that, see what it gives you. Times 2.4 gives me 38.4 equals with a question mark. And then I'm going to do 4 times 12 is 48. Again, we can see that we are not getting the same number, so these are not proportional. So it's the same answer. No, my laps are not proportional to my time. But this, knowing 2 ways to do it gives you a way to check yourself. Okay, so that's example 2. And now I want you to do on your own number 5. Pause the video while you do it, and then you can come back and see how you did. So for on your own number 5, you should have gotten an answer of yes. The number of pages read is proportional to your time. And the reason for that is because pages read would be you did 20 pages and you did 36 pages. So I'm going to do it again like I did before so I can get my unit rate. So I'm going to do 36 to 20 equals with a question mark. And then the minutes that I spent doing this, the 36 pages I read in 45 minutes. The 20 pages I read in 25 minutes. Okay, so if I try to get a unit rate for these, or if let's say I just put them in simplest form, over here, these are both divisible by 4. So I'll divide by 4 and get 9/5 or 9 to 5. Over here, these are both divisible by 5. So that gives me 9 to 5 as well. So they're the same thing. So yes, they're equal. So we'll say yes. The pages read is proportional to time. Okay, and that completes your notes for section 3.3. So what you need to do now is go in your textbook and you will have an assignment from your sub. You're going to be working through the homework problems for this section during class, and hopefully I will be back with you on Tuesday and we can discuss it from there. All right, thank you.